and welcome to this session where I will be showing you a walkthrough about the FIWARE device simulator, which recently has been promoted to the FIWARE IoT and Context Data simulator. As you will see, it's a tool you can use to simulate and to generate any kind of context data and to upload it to the FIWARE ecosystem, typically to a context broker, although you have other possibilities, as I will be showing you. So basically, this is the issues or points I will be covering in this presentation. As you will see, I will go much faster in the fifth section. I will be showing you only a couple of the interpolators available in the simulation, basically because all of them work much similarly. And I will focus more on the configuration parts, since those are the ones you will be using in your projects. So let's get started. Basically, what is the FIWARE device simulator? Well, it's a tool you can use to do many things. You can use it to update entity attributes using NGSI version 1 and version 2, typically communicating with a context broker instance. You can also use it to send notifications to subscribers, typically to the Cygnus component or to the short time historic, as a way to simulate the notifications that the context broker typically send. You can also use it to simulate, as I said, almost any kind of devices. You can simulate ultralight devices via HTTP and MQTT, and also JSON, so to call them devices, basically devices which send JSON payloads. You can also forget about everything related to authorization and token management, since the simulator is going to deal with it in the background. So you just provide the data to connect to the identity managers, and the simulators, as I said, is responsible of managing all the stuff in the background. You will be able also to run simulations in real time. I will be showing you many examples, but also you have the possibility to run what we call fast-forward simulations. Basically, that's the case when you want to generate data from the past and even from the future, and you can run the simulations. The simulator, so to say, it simulates time and moves to that time, the time you are providing, and basically updates the context broker or the subscriber, sending the corresponding requests. I will be showing you also examples of this fast-forward mode. So, well, it is also able of providing you with simulation visualizations, basically to get a dashboard about how the simulation is running. If there have been any kind of errors, the throughput of the requests sent to the context broker or the subscriber, a lot of information which you can access visually and very easily. So to say, it is somehow having the power of any kind of device in your hands and being able to communicate them with the FIWARE components. We are currently using it in Telefonica. In fact, it is one of the tools we use for all our demos. We were in Barcelona a couple of weeks ago in the Smart City Expo conference, showing our tools and platform for smart cities, and those are based on the FIWARE device simulator. Urbo is the platform, Telefonica's platform for smart city management. And as I say, we simulate all this kind of data. We simulate illumination, incidences, parking. I mean parking slots which are being occupied and freed, public transportation, buses, and so on, moving throughout the city. Also waste management. We simulate concrete containers and how they get filled and unfilled. But we also use the simulator to load testing the platform. As you will see, and I will show you, it is kind of easy to configure the simulator to decide which throughput you want to get, and somehow you can decide how which will be the charge you will be throwing to the context broker or the subscriber component. So we are currently using it to load test the Orion context broker, which everyone here knows about, but also to load test the IoT agents. I don't know if you are familiar with this component, but it's basically a layer between devices and the context broker to abstract the particularities of the devices world from the NGSI world. There are a couple of IoT agents, the ultralight one and the JSON payload one. Basically, we use the simulator also to load test these agents. And you can see here a snapshot of the Urbo platform. As you can see, there are a lot of stuff being shown on the screen. In the upper part, there is a map. And as I said, the simulator is the piece responsible of updating all the data and all the things that are happening in our simulated city. In fact, it is a district in Madrid where Telefonica is located, the Telefonica district. As I said, we are simulating almost everything, and to the concrete parking slots, to concrete containers, and for example, concrete lighting, even park watering. I mean, we can simulate almost anything. We have not found something we cannot simulate. So, very brief comment on the architecture. The simulator is just a Node.js application based on some NPM packages. So, there are three main components or elements in the simulator. The first one is the simulator configuration. These are JSON files which you will be using to configure the simulation you want to run. As you will see, it is possible to configure the service and subservice you want to use. You will be able to provide authentication configuration to manage all these tokens and security stuff. You will be able also to provide the context broker instance or subscribers instances you want to use, the ones the simulator will be communicating with. You will be able also to configure IoT agents, once again using the ultralight and JSON formats, and you will be able also to model the entities or devices you want to simulate. So the simulation configuration is really the main component of the masterpiece of the simulator we will be seeing. Another very important part are the interpolators. Of course, we want to generate dynamic data, and to do it, we provide many interpolators. So you can model, as I said before, almost any kind of data, numeric data, textual data, geolocation data, dates, as I said, almost everything you will need. The third main aspect of the simulator is that, as I said before, you will decouple real and simulated time. So this enables us to run simulations in fast-forward mode, and as a consequence, we can, for example, get into the platform data for a whole year in a matter of hours. This is very important, for example, to develop highly rich demos based on historic data, for example. And those are the packages, the NPM packages we lean on to provide this decoupling. So let's see, well, very quick notes regarding installation. As usual, we will be able to install the simulator using GitHub, cloning the repository and NPM installing the dependencies, and we also made it available through Docker, through the Docker hub. You can just get the image and run it as a container, and you will be your own. You will have your own instance of the device simulator. Once installed, you will be able to use the provided command line tools. There are two main tools. The first one, the most important one, is the one you will be using to run the simulator. As you can see, there are many options. We will be covering some of them. The most important one is the C option, where you will be providing the configuration file. The other ones are mostly related to the fast forward mode and also to this simulation visualization I was talking at the beginning. The other tool is just a helper tool to, as you can see on the screen, to be able to transpile simulation configurations. Basically, the simulator provides you with the possibility to use templates to compose your simulations. You will be able to import external files just as a matter to reuse information. For example, the configuration of the context broker can be externalized to an external file, and you will be able to reuse it in many configuration simulator configuration. It's just a helper command line tool, since this transpiling mechanism is also used by the simulator itself. So let's see how you can configure the simulator to run these simulations. The first thing you have to do, everything through this JSON file, JSON configuration file, is to, well, these are the commands you will be running many times, but this is the important part, the part where we are configuring the domain, this service and subservice pair, but also in this concrete case, the context broker you will be, your simulator, we will contacting and sending requests to. As you can see, typically you specify the host, the port, and the protocol, also the NGSI version. As I said before, we support 1.0 and 2.0 NGSI version to communicate with the context broker. Everything, once again, is done by the simulator in the background, but also you can also provide the authentication information. As you can see, we support two main providers. The Keystone one refers to the identity manager we use in the Telefonica platform, but you can also use the FIWARE Lab as a provider. So you will be able to interact with your context broker instance hosted in the FIWARE Lab, just changing this Keystone entry by FIWARE Lab. The rest of the information is basically the authentication information needed for the simulator to communicate with the identity manager and get the needed tokens. This, as I said, is the general configuration information. Probably the interesting part comes from the way you can model your entities and attributes. As you can see, there is a property called entities, which is an array. where you will be able to specify your entities. There are a couple of properties inside. In fact, there are three main properties you have to be aware of. The first one is the schedule. We will be seeing many examples. Basically, there you specify when you want your entity and attributes to be updated. In this case, we are using the special keyword once, and this entity will be updated only once. We use this kind of schedule typically to load initial data into our context broker, into our demo scenario. With this schedule property, there are another two ones, the active and the static attributes. You can see that we are kind of mixing camel case underscore notations. This is basically because we inherit the IoT agents nomenclature. In the future, we are fighting to kind of use just one nomenclature. It would be, I guess, the camel case, but we are kind of fighting on that. Anyhow, there are these two properties, active and static attributes. In the active one, you will be specifying the attributes you want to be updated, and in the static attribute one, you will be specifying the attributes which will be included in all the requests. So if I, for example, I want to include an attribute called timestamp, updated date, or any kind of date information, the place to put it is in the static attribute, since this way I will assure that that attribute will be included in all the requests. If I include it in the active property, it will be only included in the request where that attribute is going to be really updated to make it more efficient. So this is all you have to do to send a request to the context broker instance we saw before. From this point on, just let me mention that, as you can see, the schedule property can be specified at the entity level, but also at the active and the, well, in the static attribute it has not many sense, but also in the active level. In this case, if the schedule is specified at the active level, it will apply to those attributes. If not specified, it will be inherited from the entity level schedule property, just as a way to be able to model your behavior as fine as possible. So, yeah, probably one of the most interesting parts of the simulator is how to schedule updates. This is an example of an active attribute. We have already seen it. It's using the once keyword. The attribute will be updated just once. But it gets really more interesting if you use these cron-like schedules. In this case, for example, we are specifying that the attribute will be updated with a value 1 every 5 seconds. I don't know if you are familiar with this cron-like scheduling, but there you can find a reference you can use to get further information. Basically, you can specify any kind of schedule. Update this attribute certain hours of a day, any date. I mean, it's really, really powerful. Apart from this, you can also specify a starting and ending date for your scheduling. Obviously, the attribute will only be updated if the date is between those limits. Once again, the rule property in this case let you specify these cron-like schedules. As we saw before, we were updating an attribute with a value of 1. It has little sense to update attributes with static values. The real power comes from being able to generate dynamic data, and that's where the interpolators take place. We will see, as I said, a couple of them. For example, the date-increment-interpolator, which allows us to generate dates. It's as simple as that. The format is the one you can see on the screen, the name of the interpolator, parentheses, and some specification. In this case, we can specify an origin of time and an increment. In this case, for example, the value of the active O1 attribute will be set on each request to I don't know if this is a year or, I mean, those are 86,400 seconds. I think it's a year. So it will be on each request being updated with a value equal to a year later. We can set the origin to now, but we can also set it to a concrete date. Probably the real interest comes from using the now version. So you can, as I said, for example, we use this interpolator in this waste management model we have to set the time where the containers will be unfilled, where the truck will come and get all the trash from the containers. You can see that there are many interpolators. I don't want to get into much details. For example, this time-linear-interpolator allows you to get linear interpolators based on the time of the day. For example, in this spec, you can see there is an array of arrays, of 2 elements array. The first one is the decimal hour of the day. The second one is the real value of the linear interpolator. Once again, we are here simulating how a container gets filled. For example, at 8 o'clock p.m., the container will get a value of 25. At 9:50, in between, it will be interpolated linearly. So basically, you can model this kind of behaviors. You can also get integer data using the typical rounding mechanisms provided by JavaScript, floor, ceil, round, instead of floats, if you need it this way. We can also make some random data using this time-randon-linear-interpolator. Basically, it will allows us to use the random directive, as you can see on the screen, to include some randomness on the date, on the hour part, but also on the value part. In fact, we can use it in both at the same time. So in this case, for example, between 0 and 1, it will be getting a value of 0 randomly using the random JavaScript generator. Once again, you can get the data as a float or as an integer. We also provide this time-step-after-interpolator, which allows you to simulate these staircase interpolators. Basically, once again, you will be able to set the decimal hour and the final value the interpolator will be generating. For example, in this case, from 8 p.m. on, it will get the value 25 until 9 p.m., where it will get the value equal to 50. Just as we have the time-step-after-interpolator, there is also the time-step-before-interpolator, which basically is the opposite. In this case, from 8 p.m. to 9, it will be getting the value of 50. Between 9 and 10, it will be getting the value of 75. Once again, another typical interpolator to allow you to model your concrete data. As I mentioned before, there is also the possibility to generate textual data. For example, this is the interpolator we use in these incidences simulation as a way to make the incidences evolve through states. Once again, as you can see, you can specify the concrete second where the incidence is evolving to a concrete status. We also use this interpolator to model parking slots, to specify when the parking slot is free or occupied. You can use it to your needs anyhow, any place you need to generate textual data. There is also a geolocation interpolator. I won't get into the details because it's on the documentation, but as you can see, you can generate routes and specify the speed the mobile element will be getting. Also, you can specify a starting and ending time. The interpolator will be generating the concrete position of the mobile or the vehicle at its precise moment. Recently, we included the possibility to generate this information also as geopoints, since to the moment we only provided as GeoJSON, basically because in NGSI version 1, the context broker only managed the geopoint option. Those are some of the simulators you had at your disposal, but we needed even more flexibility. We needed the possibility to generate data based on code, so to say it. So we included this attribute function interpolator, which basically allows you to execute any JavaScript code and return the value you want to set to the attribute. So this is the simplest example of the attribute function interpolator. We are just passing a value, 1. This value will be evaluated by JavaScript, and obviously the result will be also 1. But the real power comes from cases such as this one. In this case, you can see that we are using a templating mechanism to get the final value. In fact, here what we are telling the simulator is take the value of the active1 attribute from the entity name O1 entity and add the second power of the active1 attribute of the entity name 2. Entity name 2 entity. So you can do this kind of numeric expressions to generate the final data which will be assigned to your attribute. You can also, well, this is the code without all the burden. This is the code you will be providing to the interpolator to generate this data. Here, a more complex example where, as you can see, you can also use requires. You can require almost, any NPM package to generate your or the final data which will be assigned to the attribute. In this case, we are using the postfix calculate NPM package, which uses the format you can see on the screen, operator sign to get the final result. In this case, we are getting the active1 value of the entity name O1 entity and adding 1 to the to that value to generate it as the final value to be assigned to the attribute. So say, can almost do anything with this interpolator. In fact, you can also, well, this is once again the code without the burden. You can also get access to the what we call the simulation date and time. Basically, as I said before, we can run the simulations in a fast forward mode, and it is important for the interpolator to know the concrete simulation date which must be used. Basically, we provide it by means of this simulation date object. So you can decide the final value to be assigned to the attribute based on the simulation date. You can also use this attribute to manage a state. Let's see directly the code. This is the code we are providing to the simulator. As you can see at the beginning, we are using a comment to specify the state we want to be maintained between attribute function interpolators execution with the same specification. In this case, for example, what we are getting is the active1 attribute of the entity name O1 entity incremented by 1 depending on the execution of the interpolator. It will be basically be incremented by 1. Another quick example. Just for you to know the possibilities. As I said, those are deeply documented into the documentation. You can also model global state. This is the way you will be doing it. Just as we specified local state, the global state is maintained between or amongst all the instances of the attribute function interpolator. Basically, for example, if I need that an interpolator uses some data generated by an external interpolator, this would be the way you can pass global state between attribute function interpolator executions. Once again, this is an example mixing both of the state management capabilities. There is local state and also global state. As I said, with all this you can model of almost anything in your concrete scenarios. Well, I don't know if you are familiar with Node.js. It's an IBM platform to build these kind of flows, these IoT flows. Well, this is an example which attends a request and basically responds with say hello. Well, we can use the attribute function interpolator to access Node.js using code such as this one. Once again, it's just JavaScript code which gets evaluated by the interpolator. The final value is generated dynamically and passed and assigned to the attribute, the concrete attribute I want or we want to update. So as I said, all the JavaScript power at your hands. Just as you can update attributes, you can also update entity attributes metadata. Everything applies just the same using this notation. Instead of assigning an interpolator to the attribute value, you can include this metadata property, which as you can see is an array, and you can use you can assign the value of this metadata to any of the interpolators we just saw. It works exactly the same. For example, to generate timestamps of any other information you want to add as metadata to the attributes. There is also the possibility to generate many entities on your behalf without specifying them. It can be used. It can be done using this count property. Basically, we specify the number of entities we want to generate and its or their type, and the simulator will generate those entities for you. For example, we use it for this load testing I was mentioning at the beginning. Just as we saw, we can make the simulator interact with the context broker. We can do exactly the same with subscribers. As you can see, instead of specifying the context broker data, we can specify the subscriber data. In this case, it's the typical data and path used by the short time historic, and instead of sending requests to the context broker, the simulator will be sending notifications to the STH component in this case. Once again, everything works just the same as we have seen so far. Once again, as we can configure context brokers, subscribers, we can also configure IoT agents. Instead of specifying this subscriber property, we can include this IOTA property inside. We can specify the data to interact with the IoT agents using the distinct formats and protocols. Just specifying the needed information, the simulator will interact with these IOTAs to update the attributes of the associated entities. In the case of the IoT agents, you have to model devices, not directly entities, and for that you can use it using the devices property. It's pretty similar to the entities one, but it uses some protocols needed by, some properties needed by the IoT agents, such as this object ID, the protocol, and so on. But as I said, the simulator will be doing all the magic in the background for you once you specify the information properly. Once again, you can also use this count property to simulate many devices. In this case, we are generating 5 devices of device type 03. The simulator will do it for you. We include the possibility to use using templates into the simulation configuration. It's what I mentioned before regarding the possibility to send to an external file parts of your configuration and using them in many or several configuration files. You can use it using the exports property. This is an example where all the information is included into the same configuration file, but you can also store into a file this, for example, this context broker in GSI v1 content, and you can also import it if not found inside the exports property. The simulator will try to find it into the file system, and it will load it for you, and of course use it as specified. So it's a way to reuse configurations more easily. We had the need to make it even more complex. This is an example for you to know that it is also possible to decide based on conditions, regular expression conditions, which content should be used for each concrete template. For example, we can specify that for the name attribute of certain entity, I want to use this content to be imported, and for that other attribute, I want to import any other configuration information. Once again, just for you to let you know that there is also this possibility available. So finally, we get to the fast forward mode. Once again, everything works just as we have seen, but the possibility to set a starting date and an ending date is all you have to do to get your data simulated. As I said, the simulator will decouple real and simulated time. I will contact the context broker, the subscriber, or the IOTAs, sending the simulated time as the time of the update. This way, as I said, we can also we can generate historic or future data, just as in this example, to have richer demos. If we run this command, we will be seeing on the logs that, as we wanted, the simulator is sending update requests, in this case, to a context broker instance on the dates that we have configured. As part of this login information, we also provide, as you can see, progress info about the simulation, and there you can see, for example, in this case, the total number of updates, the error ones, the one which has been delayed, the pending time to run the whole simulation, the simulator time, the real time. So all the information we have available is shown on the logs. In fact, this is the information we also use to generate these visualizations I will be showing you in a sec. In fact, there we are. This is an example of the command you can use to generate simulation visualization. We lean on date.io and FIWARE.io to generate this visualization, and basically you can get this kind of, the one on the right, this kind of information. Dynamically, you can see the number of updates which has been sent to the target, context broker, subscriber, IoT agent, the number of errors, any concrete error which may be raising. You can get all that information on a graphical way. By the way, as you can see, the simulator command line tool is kind of complex or rich regarding the options it may take. There is also the possibility to pass this X option, including a path to a JSON file where all these options can be specified. And you can get this clearer command on your screen. The result, of course, would be the same. You get the same visualizations. Just to conclude, let me share with you a couple of references. Basically, the GitHub repository and the read the docs documentation. As I said, we put a lot of effort on the documentation. All this is detailed there. I just wanted for you to have a glimpse of all the possibilities you have available. But obviously, if you want to use them, you will have to get deeper into the documentation to see how you can use any of those capabilities. So that will be all from my side. If you have any questions or doubts. Yep. Currently not. You cannot do that, but you can use these random directives to include some kind of randomness in your generated entities. But to that level of
So in that case, in each entity, the randomness would be different.
sorry, the one?
The randomness would be different.
That's right. Yeah, yeah.
Another question, let's say I want to do some log testing, so I want to do, for example, 10,000 entities. Do you have the limits that we get?
basically, to do that, you can play with a couple of, let me go back to the slide about the command line tools. You have a couple of options. Oops. Well, it's this one, where you can specify yeah, the throughput you will be applying. It has obviously consequences on the RAM memory usage. They are these D and M configuration options. The most important one is the maximum not responded requests. So you can specify the number of requests that will be sent to your target without getting a response. With this configure parameter, you can basically yeah, control the charge, but also the RAM memory consumption and any other consumption, CPU consumption. That's the configuration parameter we tune to play with this. Also the delay, but the most important one is the M1. Thank you. Any other question? No? Okay, thank you very much. Let's move to